So, we were discussing about triglycerides, that is the fat, right. In general, we have discussed in many, as we said. So, today is our 23rd lecture. So, in that we will continue discussion with fat, right. So, typically milk fat that we will discuss. So, to do that, you remember last day we finished at this point that size of the fat globule can vary between 2 to 30 somewhere around this micron in size. There are many which are less than 20, but very few more than 20. So, that is why generally it is said between 20 to 2 to 30 microns. And also you said a drop of fat globule, and a drop equivalent to, I said, if you remember, that we take in pipette or burette. So, that drop which comes from pipette or burette, that is generally taken as a drop, and this droplet. So, this droplet size is roughly 0.05 millimeter, milliliter, right. Millimeter is the unit of one dimension, milliliter. So, that is the volume. So, in that 0.05 one droplet, one that is one what we saw, one in drop or one droplet of milk, it contains around 10 to the power 8 number of fat globules. So, imagine, so how many fat globules you consume when you are consuming a glass of milk, maybe 1/4 of a liter or half a liter or some things like that. So, so many droplets you of or so many number of fat globules you are taking, right. So, in this fat globule, so we also said that there is a membrane which protects the fat globule, right. So, that we said fat globule membrane, that is FGM, right. Now, if we come to composition of milk fat, then it is not a single chemical compound, it is mixture of several different glycerides. The other day I said that milk fat contains around 98% triglycerides. If you remember, we had said that around 98% triglycerides, some sterols and some others, maybe phospholipids are there, right. So, organic acids consisted organic acid, those are in milk, fat, and fats from other sources other than milk fat are commonly known as fatty acids. So, this fatty acid we have already discussed, right. So, animal fats are relatively simple as compared with milk fat, because they do not have so many complications, because so many numbers of fats are not present. Whereas, in milk fat, we said the other day around 400 this your fatty acid groups could be associated, if you remember, we had said, right. So, it is really a vast number of fatty acids associated with the milk fat, but it is not so tricky or it is not so complicated in case of if the fat comes or fat is obtained from animal source, right. So, let us look into beef fat. This contains around many triglycerides, okay, and they are palmitic, stearic and oleic acid, right, consists of glycerides of palmitic, stearic and oleic acids. Mutton tallow, that is glyceride of stearic acid. So, beef fat, mutton fat, they are, and mutton fat is known called tallow, right. And in some cases they are also called lard, animal fat, right. So, there it is another. So, it is much simpler. You see, we said that palmitic, stearic and oleic, this is for the beef fat, whereas in mutton fat there is tallow, it is only glycerides of mainly stearic acid. So, it is much simpler. In milk we have seen it is n number of such kind of fatty acids are present. So, that is why we said that animal fat is much more simpler compared to that of the milk fat. Lard, another animal fat, which is glyceride of oleic acid, right. Lard is a glyceride of oleic acid, though these of course, if you remember the other day we said saturated, unsaturated. So, mostly these are unsaturated, saturated fatty acids, and that is why their value is also not so high, right. I gave also the example of the market. If you go to the market, then you get lot of fats of animal, of different animals, right, and they are normally either thrown or maybe sold at very nominal prices, right. The primary reason is that they are containing very simple types of glycerides and mainly the higher number of carbon atoms, C16, C18 like that. So, the palmitic, stearic, oleic normally they confined to these, right. So, but in milk fat, if you look at milk fat contains butyric acid, caproic acid, caprylic acid, capric acid, lauric acid, myristic acid, palmitic acid, stearic acid and oleic acid. So, it consists of everything with small chain carbon, with long chain carbon, right. And if you remember, we had said the generally naturally available these fatty acids, they range between 2 to 20 around, right. Beyond 20 it goes to what? You remember? Yeah, it goes to waxes, right. Beyond 24 it goes to waxes, that class, right. But they are also lipids, all are under lipid family, and here we see both small chain carbon carboxylic acid and large chain carbon carboxylic acids are present in milk, right. So, they are butyric, capric, caprylic, caproic, lauric, myristic, palmitic, stearic and oleic acids, right. So, because of the presence of so wide variety of your this acid, that is the carboxylic acid, that is fatty acid. So, they are both volatile and non-volatile components of the milk fat which comes out, right. So, milk fat contains both volatile and non-volatile. As you see, those which are soluble and volatile acids, they comprise of butyric. You remember the other day I said that odd or even, it depends on how you are defining. If you define taking carboxylic acid as the unit also, then butyric acid becomes 4, C4. But if you remove carboxylic acid and only concentrate on the chain of the carbon length, then butyric acid becomes C3. So, like in this case, we are giving example of C3. Earlier we said that those which are available in natural resources or natural sources, they are primarily of the even number of carbons, right. but here it is being seen that if we remove that carboxylic acid group, then it becomes C3 for butyric acid. Similarly, for caproic acid it is C5, for caprylic acid it is C7, for capric acid it is C9, for insoluble and non-volatile it is this. So, the soluble part, the soluble volatile part is between C3 to C9, less than C10, or if it is in odd even number, then with the acid we can say C4 to C10, including the carboxylic acid group. But if it is without the carboxylic acid group, then it is C3 to C9, right, like butyric, caproic, capric, caprylic, all these are soluble volatile fatty acids, whereas insoluble and non-volatile fatty acids are consisting of comprises of C11, that is lauric acid, C13, that is myristic acid, C15, that is palmitic acid, C17, that is stearic acid, and also C17 for oleic acid, right. So, all these are non-volatile fatty acids components, whereas volatile fatty acids components are less than 10 and more than 10 are non-volatile. So, this 10 I am referring with respect to both, whether it is odd number or even number. It does not matter whether it is odd number or even number, it is less than 10. Does not matter whether it is odd number or even number, it is higher than 10, greater than 10 for insoluble ones, right. Now, again hardness or softness of milk fat and their relation to the texture of butter, that depends primarily on went to non-volatile group of the fatty acids, right, which constitute around 82.7% non-volatile group of fatty acids. So, non-volatile group means more than 10 carbon length, less than 10 was volatile. So, non-volatile group of fatty acids, that is between C11 to C17 without the carboxylic acid group, right. And out of that around 82.7% is the non-volatile fraction of the milk fat, right. Next, we come to that the rancid flavor that sometimes occurs in dairy products is largely due to the liberation of the butyric acid. I do not know whether in any of the laboratory you have seen or not. You go and see that we take butyric acid, generally in chemistry labs this is available. So, you go and get butyric acid and take a smell of it, you just cannot, it is so obnoxious that you just cannot. The moment it comes to you, automatically you will get a jump or you will take a jump, right. So, that is primarily because butyric acid is very bad, very off flavor. So, that is what is liberated when milk becomes rancid, right. And rancidity can be caused by many things, like it can be enzymatic rancidity or it can be oxidative rancidity. So, depending on what, but generally the products could be similar or alike. So, it is butyric acid is one of these product which comes out from the rancidity, and that causes very off flavor. So, if milk is not consumed and if it is getting rancid after some time, then the off flavor which comes out from the milk is primarily because of the butyric acid, right. So, this you keep in mind. Milk fat does not have a true melting point. Why? Because whenever you are finding out melting point, whatever be the process method, whenever you are finding out the melting point, you have seen that the melting point can be determined if you have a single component exactly, right. You can tell ice has a melting point of 0 degree centigrade, right. But if you have ice, dry ice combination, then can you say that it has a 0 degree melting point? Not at all, because that is a mixture and both of them have different melting points. So, it is not a single isolated melting point as it is. So, that is what when we are considering milk fat, it does not have any single point melting point, because it contains many triglycerides, many fats, and that is why it is not a single component, it is a range, and this range varies between 29 to 36 degrees centigrade. This range varies between 29 to 36 degrees centigrade, right. The solidifying point of the temperature, the solidifying point or the temperature at which milk appears solid, that also varies, and this is between 10 to 12 for the same reason as the melting point is different, solidifying point is also different. Of course, normally what we know, like for ice, we know that it is melting and also solidifying both at 0 degree centigrade, because that is a single component substance, but here it is a mixture. So, that is why the ranges are different and melting and solidifying points are also quite different, right. So, the solidifying point or the temperature at which milk fat appears solid is around 10 to 12 degrees centigrade. Specific gravity of milk, again specific gravity is a function of temperature. I hope you have not forgotten that in school you have measured specific gravity in a specific gravity bottle, and if you remember that in that bottle it was specifically written that at such and such temperature, right. Because why? Because your specific gravity bottle, when you have taken, you say this is the specific gravity bottle by any chance. If this is the specific gravity bottle, you have taken the liquid inside. So, the weight which you have taken is not changing with temperature, but what is changing with temperature? The expansion or contraction, that is the volume. So, since the volume is changing, so that is why the specific gravity is always mentioned at a given temperature, right. You will see the same material will have different specific gravity at different temperatures, that you just look into any substance, any material you take, be it food or non-food, does not matter, but it is that the specific gravity is a function of temperature, right. So, specific gravity of milk is 0.9 at 60 degrees centigrade. At 60 degrees centigrade, it is 0.9, right. Now, factors which influence the composition of milk as we said, that there are many factors. Some of them we discuss here. If possible, in future, if we come across similar topic, then we may discuss some in more. But the primary factors for which the composition of the milk fat varies are because of the principal fat known to vary is because of is butyrene, olein, palmitin, stearin. These are the principal fat which are responsible for majority of the fat, that is butyrene, olein, palmitin and stearin. Now, factors which are responsible for variation of these fat content are breed of the animal. We said earlier, breed of the animal, say you are taking cow. So, that breed, whether it is Jersey breed, Holstein breed or say some Indian breed, obviously the fat contents are quite different. I do not know, we had one dairy farm in our institute, and there we had seen that from Australia this Jersey cows came, and their size is so big, so beautiful health, so stout, and they used to give both the quantity wise much more, as well the fat content was very high compared to when we were considering from our house to house some or other kind of cow animal, right. So, it depends on the breed for the same animal breed, and afterwards you will see from the same breed species to species. If that breed, whether it is Indian variety or Australian variety or Netherlands variety, whatever we eat, the same breed of different species, right. So, they will also vary differently. This will come. Then stage of lactation. Stage of lactation. So, after the birth of the animal, so that is called the lactation period, and this is generally up to 1 year, and this is that varies, this lactation period, because of the variation of the lactation period. The contents, that is butyric acid content, declines from the beginning to the end of the lactation period, right. In the beginning, butyric acid content is high, whereas towards the end butyric acid content is much lower, right. So, that is why I do not know how many of you, again I am referring to this, how many of you have ever visited any such units where at home or domestically the animals are reared, and you went there and took the milk from the cow, and that time your seniors, if you are first timer or may not be that much experienced in bringing milk every day. So, then you might have been told that be sure that in that house there is some cow has given some birth of the calf, and do not take milk from that, right. That could be the smell of that is quite different, the fat contents are different, all are different. That is why lactation period is a major cause for the differentiation in the fat content as well as the composition of the fat. Then primarily feed. Feed is a very vital component for the variation. Why? Because particularly in our country, all over the country you will see that yeah, in many cities or metros nowadays, those kind of milk house rearing facilities are not allowed because of the urbanization. But in villages you will see lot many are there, and what they do, they allow the animal to go here and there and get whatever food they want. But this is not so in any developed countries. In any developed countries, they do rear commercially, and there are maybe hundreds and thousands of animals are being reared, regularly fed with the good food which is suitable for them, and those animals do also pay back the output as well as the fat content of the milk. So, that kind of commercialization in our country, I do not know when it will come. At least several decades back, there was a white revolution by our respected Korean, and after that such kind of revolution or such kind of thinking is not coming up. So, I hope my students who are now listening, if they come to the apex body, they will take care of this kind of problem, that they let there be consolidated rearing of the animals, so that the rearing becomes also easier, as well your this thing becomes very fruitful. So, feed is one such. It is not that they go around and take their food accordingly. Now, feed, so increase in olein content produces soft fat with low melting point. For cottonseed meal, increase in olein is counteracted by the decrease in butyrene. Feeds result in higher olein content rich in vegetable oils such as linseed meal, soybean meal, etc. Grass pasture increases olein content, feeds with low vegetable oil but rich in carbohydrates, produces less olein content, that is farmer fat is available, right? And nutrition, that is decline in the volatile acids and increase in the olein content. So, these are the some of the different reasons why the variation of fat content both in quantity as well as composition for the milk, it varies, right. So, here we stop because time is up, we stop it here. Thank you.